Hey and welcome. Today we will solve remove duplicates from sorted array interview question, which mostly asked by Apple. So let's dive in. First example here. Basically what this question asks for is that we will get a sorted array and we might remove any duplicates from it in place. And as you can see here, we returned only 1 and 2. By the way, we might return the index where the array stops being unique in our result. Second example. Again, same scenario. We have a bunch of numbers in an array. After removing the duplicates, we will end up with this mutated array and we return the index which the array stops being unique. Before getting into the solution, let me show you something in the question description first. I want you to pay attention to this part of question's description. The way that leetcode's test or output is going to be checking which index we return from our function. It will iterate over the same array as much as that index and checks if numbers are correct. So takeaway note here is that it actually does not matter what we do with rest of array. And as long as we have correct values in correct indices, we are fine to go. And that is why they are underscores. The rest of the array, which could be confusing for some of you at first. As of a brute force solution, I quickly came up with a solution by using a splice method on the array, which by the time of recording this video, leetcode actually still accepts this solution. But quickly after, I realized that splice takes O of n time complexity to execute. So we are literally looking into O of n squared solution right here. The best way to approach this problem would be to get inspired from this solution here, plus a small trick. The trick here is to keep track of the index of unique values as well, separate from the iteration through the array which has its own index. What we need to do is compare each value in iteration with the element of array that unique values pointers gives us. And as soon as we see a mismatch, we just increment the pointer of unique values by 1 and replace the array at that mismatch index with the value we have in our hand from iteration. Also just notice that we started the array iteration from index 1 to give us a bit of room to compare the element with previous one. This process will repeat one more time at this point. Again, we will do the same, increment the unique values pointer and replace the value at that point and continue our iteration again at this point one more time and one last time at here. Now we are done with our iteration, but look what unique values pointer holds for us. The same index that we were looking for, right? So at this point, we should not care about the rest of array and return it as a benchmark from function, which will tell to our custom judge that in which index it has to stop checking. Now let's jump into the code and start implementing this. So first we need to create our variable to store the index of unique values, which obviously will start from 0. Then our iteration over array, but notice that we are going to start it from index 1 because we need to have a bit of room to be able to compare element with previous one. Now it's time for checking the mismatch. We will compare the value at index I, which starts from 1 or iteration, with whatever we have as unique values idx variable. If those two elements does not match with each other, then we might update our pointer first. Remember that unique values idx, as its name suggests, will only going to keep track of unique values. So it makes sense to increment it when we see a mismatch between previously duplicated values and the new one that we are finding. And then take care of the replacement. Finally, at the end, we will return the index where we tracking through this algorithm, but plus 1. Well, there are two scenarios for your question of why plus 1, but let's run this first and I'll explain it right after. Tests are passing, and if I submit this, seems like everything is fine. First scenario is it will act like a safety guard where we only have a single element inside of array. What will happen is that we will never get inside of our for loop because we start from index 1. And obviously that index is undefined in this array. And finally, the returned result will be 0 in that case. But still, there is an element inside of array which is unique, right? So that was the first scenario. The second scenario is again about the same starting from 1 instead of index 0 in our for loop. The point behind skipping the first element was that to give us a room to compare the value with its previous one, right? So we already skipped one unique value there and started off with second one, which was in consequence of finding new unique values through our iteration, right? So that is another reason for that plus 1 actually. Now let's talk about time and space complexity. For time complexity, we will have O of n, where n is the elements in array. We have to finish iterating the array before returning the index that our unique values idx variable holds for us, because who knows, maybe we find another distinct value at the very end of array. For space complexity, it will be O of 1 because we just created a variable and everything else happened in place. The replacement of elements, I mean. So that was it for this video. Thanks for watching, and please leave a like, comment and subscribe to the channel. I will put the link for arrays playlist in the description to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.